Hello everyone, this is the demonstration video for data capture lab and how the data from the microphone can be used to detect the anomaly in the fan. So basically this is just a demonstration for the fan. Actually this is so since it is locked down here and I don't have enough resources here, so I could not get my drone here to record the data, so I'm just simulating the same thing with a fan which is also running at around 2 to 3000 rpm. So this will be example for the fan which will be used in the drone. So yeah, so drone rpm will be somewhere around 4000 to 5000 in the case of heavy payload drones, and low payload drones will have rpm of around 9000 to 11000. So basically here the thing is the data from the audio data from the fan is directly being faced to the microphone here. So there is a MEMS microphone inside the quick feather which is open towards the board end, so that's why I have kept it like this. So and cable is connected to the laptop, and here the data capture lab is running and it is recording the data. So most of it is my voice right now, so I'll show you how it responds for the anomaly like this. So here what I'm doing is I'm just interfering with my finger, so that is one thing. So yeah, so I can even simulate the loosen screws here by making it little bit loose. So here you can see that the audio is different right now. Yeah. For the event broken propeller, here I have a CPU fan which is like most of the arms are broken here. So you can see that propellers are broken and only 3 are remaining. So I'm using this for the simulation of broken propeller, and here is my quick feather, and here is the data capture lab recording the data. So I'll just turn it on. So you can see that there is a huge vibration here. This is the final demonstration video of the SAS project. So here you can see that I have connected the fan, and quick feather is here, and we have these many data sets like results. So these are the numbers for that, and if I go to the terminal, we can see here the current operation, what and all it's going on, it's coming here. So yeah, so currently I'll just turn it off so that the function goes to number 5. Here you can see that it is coming as 5, which means according to our this thing is stationary. So yeah, so I'll let me just turn it on and give some obstruction to the propeller. So like this, I'm gonna give a continuous obstruction here. So here you can see that the model detected is number 4. So it quickly detected number 4, saying that obstruction to the propeller. So yeah, as a further improvement, we can add a Raspberry Pi, and instead of connecting it to this USB to UART converter, and I can directly connect it to Raspberry Pi's UART pins here, and then I can directly use the Raspberry Pi like Python program to upload the same thing to the ThinkSpeak cloud or any cloud based on the requirement.